How's it going? Figuring out the screens right now. There you go. Thank you. Thank you for all of you who've stayed behind for the last definition of serverless for the day. It's true. So a little bit about me first. I'm the CEO and co-founder of Zeit, builders of a lot of awesome dev tools. Our platform for serverless is called Now. You can go to it at now.sh. And a fun fact about me, I'm from Argentina. So this talk is not going to be in English. It's going to be in lunfardo, which is a variant of Argentinian Spanish mixed with Italian for the purpose of dancing tango. I don't know Italian, but I think that's what it says there. Cool. Actually, like he said, I now live in San Francisco, so the talk is going to be in English. Okay, so one term that I want to introduce that I haven't heard of today that I think is really insightful is serverful. Because we talk about servers and we talk about serverless, and I feel like it's not symmetrical enough. So this talk is actually about talking about serverful to serverless. So let's get this last definition out of the way. So what are the questions that come up in my mind? Is serverless a cost model? Is it a security model? Is it a programming model? Can a container be serverless? CC Bread and Cloud Run. Is serverless a religion? That's a good one. I'm thinking that it is, based on some of the talks I've heard. Can a server be serverless? This one is one I spend a lot of time thinking about. Can a server be serverless? Because we see that a lot, and this is my reaction. Can a server be serverless? Okay, so my principle about this is that opinions are like butts, and everyone has one. Socrates? Not really. Definition of servers are like butts. Every platform has one. So depending on who you talk to, like me, who has a platform, will give you a different definition. But since it's the last talk of the day, this is the one definition that you have to hold on to. So my definition is actually quite novel, I think. I haven't heard it today. So it's very simple. If you deploy and operate a scheduler, you're serverful. If you deploy code that gets scheduled by something else, you're serverless. So it's that simple. Kubernetes, serverful. It's literally a distributed process scheduler. Containers, this one will throw you off. Serverful. Why? Because inside the process, you typically have to deal with a scheduler. Functions, serverless, because they're invoked by the platform. That's why we talk about invocations when we talk about serverless, or a lot of us do. This one is the one that throws you for a loop. Servers inside functions, like if you take Express.js or a Node HTTP server and you put them inside a function. Serverless. Why? Because you're still being invoked by the platform. Whether you're writing server code, perhaps fights off the abstraction a little bit, but because it can't be made to work, I'll give it a serverless with an asterisk. And some of the caveats have to do with, for example, granularity, which I'll talk about later, and making some sacrifices of the security model that you get from serverless when you deploy a server with multiple routes inside. And then there is the discussion always of cold boot times. If my server keeps growing and growing and growing, one day I'll hit the limits, and I'm really not taking advantage of the platform. Static sites is another novel introduction I'll make, are serverless because they're invoked, quote unquote, they're served directly by the platform. So my definition is very broad and very nice. So Knative is interesting, right? You kind of are serverless and kind of are not from this perspective. So this introduces the general theory of relativity and the calculus of serverless. So from the developer point of view, a technology like Knative is serverless. Great. From an SRE and ops point of view, it's moot. It's kind of serverful because you're still operating the scheduler to some extent. Even when it's managed, you're scheduling nodes, you're deciding on node count, etc. The calculus is, from the organization point of view, you're serverful. So the calculus is really simple. If any of your constituent parts are serverful, you're serverful. If you're all serverless, like the talk before, you're serverless as an organization, which I think ultimately is what we all should strive for. And I think every step along the way, and I like the conclusion of the previous talk, you'll probably shed a lot of the server full weight until you're fully serverless. And what does it boil down to is to schedule or to be scheduled. That is the question, Shakespeare. And I think from that perspective of whether you're being scheduled or you're scheduling yourself, serverless is superior for a number of reasons. So one of this is operating schedules is very hard, even when they're managed. No one said this ever in their life. I'm exhausted. I woke up at 3 a.m. to reboot my serverless function. You're never going to hear that. Schedulers tend to require constant health checking, which is really annoying. And developers tend to either forget or not write good health checks. Developers themselves are bad schedulers. So I imagine this conversation happened in a lot of organizations. Someone finds out that an API is slow, whether monitoring or metrics, or someone goes to the website and it's slow. So someone goes, okay, let me just quickly adjust the dyno count. And they over-adjust it. So let's throw 20 dynos at the problem so the API is fast again. Or someone says, let me quickly scale this replication controller or this deployment to an arbitrary number. It doesn't matter. The goal is to make the API fast really quick. And then the DevOps people, with pressure from the build that keeps growing, are like, no, like, the solution is to rewrite the code. So the TLDR is developers should not be the ones scheduling nodes, scheduling container counts. Arguably, they should not be deciding on concurrency settings either, because they're pretty arbitrary. So the other insight is that, as I mentioned earlier, inside the process, you typically have to deal with a scheduler. So something really funny happened a while ago. This is pretty recent, actually. In August in 2018, someone reported with a really funny avatar on the Node core repository that after 25 days, set timeout stops working. Yeah, I'm not kidding, or set interval. It stops working after 25 days. So if any of you are running daemons or servers and they're running Node and you have set interval, leave this presentation now because your processes are going to get stuck. So actually, no, it was fixed, but it took a lot of research. In fact, even just to reproduce this, someone had to use a library called libfaketime to accelerate time and space. Because how do you debug this? Wait. Let's wait 25 days to see if I can repro, right? But this is why I don't like servers that run forever. So no one has ever said this either. After a month, after 25 days, CloudWatch stopped invoking me, right? No one ever. Nobody, no group. And who wants a process to live forever, therefore? You don't want that to live forever. So that's what Freddie Mercury said. And who wants to be a scheduler? No one. No one. So another part of my definition is that it doesn't really have to do with statefulness or statelessness, because that's also very relative. So a state does exist and persist, especially as we start debating hot and cold functions. So Jan Kui, who I don't know if he's still here, he's going to like this, said, what are the weirdest, most glorious hacks you've seen around AWS Lambda? Challenge accepted. So what I did is I created the most inadequate use of Lambda that you could think of, which is I created an emulator of Pokemon Yellow that executes one invocation at a time as you refresh the function. So you're going to see here, this is the first frame of the Pokemon Yellow game on Game Boy. And every time you call it, the Lambda retains the state of the emulator. And if you keep calling it and you happen to find that Lambda, it's going to continue the emulation 20 frames at a time. So it's kind of like this lazy emulator that is invocation-based. If you're not observing it, it's not running it. If you're observing it, it resumes. So this is pretty nasty on itself. So it gets more nasty. So what I did is I put it inside JS bin, and I refreshed my function nonstop. So now I have an emulator that runs by itself. And this is not accelerated at all. This is kind of a testament to how good the Lambda resumption is. It happens very fast, so much so that I can play the game in real time. But the reason that Lambda is not fully stateless is that I'm leveraging global state here. In fact, that's how the emulator works. So this is my now.js function. I export my request handler, and then I run the emulator. And the emulator is kept in global state. So there is a state, and I'm taking advantage of it here for performance reasons. And actually, this is a really good thing, right? Because In Node.js, boot up time is not instant. Requiring all that stuff that goes inside the Node module's black hole is not instant either. So this is a great stateful feature of Lambda. So what I did next will shock you. I put all the state into Redis, and I actually made the whole game work across invocations, and you can even restore it later on. So I'm going to show you really quick that it's not. Again, you're not supposed to do this, but it works. So why would you do it, someone asked. Yeah, because I think this is very instructional. If you're teaching how state works in Lambda, going through this example and making everyone collaborate across tabs for this game to run is very, very illustrative. Another really cool thing about this is that the game actually only runs while I'm looking at it. So much so that if I close the tab, no one is going to request it. The game is going to pause until the next time. So what do I consider to be the most minimum viable serverless app? From our definition from our platform, is a basic thing is a combination of static files that get served by the edge and functions that get executed on demand. So a critical distinction here that containers are not going to give you is that when you make a deployment of your functions together with your static files, they go to a global CDN. So if your static files, for example, your front end, lived inside your container, you would always be going to one fixed location. If you take advantage of structuring your project separately, you can put things in the right place. So, for example, when I deployed it, I can see that my outputs are two functions with two independent sizes, which will help me with cold boot times, for example. So if someone accesses the info lambda /info.js, they get a smaller one. If someone accesses my emulator, they get a massive one because I had to embed an HTML5 canvas emulator. And then my static file gets served directly from the edge. So every time I go to my front-end application, it's instant. And yet the deployment strategy is always the same. Just deploy my entire repository. So this model works really well, but there are some challenges still. So first of all, it's a departure. When people write applications today, they don't think of breaking everything down into independent files, for example. So now our platform does make functions a lot more approachable. For example, in this example, all I had to do was I created an index.html file. I referenced a route, like /fn.js. I exported my handler, which, by the way, matches the Node.js signature exactly. There's no notion of an API gateway or anything like that. I'm just writing a regular Node function. And then there's some configuration associated with this. So this is the part that I'm going to go into now. So why is there a configuration? So one thing is Lambda and serverless functions have different runtimes, as you know. So in this case, I want to say to the platform, hey, this particular function is meant to be the Node runtime. So this is why we introduced this concept of builders. So what a builder does is it takes my code and packages it for the appropriate infrastructure that I want to deploy to. So in this case, it gives me the ability to have multi-language without really having to tie myself into the specific APIs of the infrastructure provider. Even ours, it's just the Node or Go APIs in this case. These modules are open source, so you can write your own to package your functions or files however you want. And you can publish them and reuse them. But the really, really, really cool part is that without needing Docker, you can actually run all of this and reproduce it locally. So typically when you develop in Node, you don't go and try to fetch the Node binary from inside a container. You typically just go to your terminal and you write node index.js. So that's the developer experience that we want to mimic, is you probably are already developing in Node using your local tools. So by just running a lightweight wrapper around this, you continue to use your local tools, which gives you very low latency when you're iterating on your project. So everything is awesome. We're done. Let's ship it. There's nothing else to do. Actually, there is a few remaining challenges. So one is, that we hear a lot, is, well, there's actually too much config. When I write an Express server, I write server.js or app.js, there's zero config. And Docker does introduce a level of config, but the abstraction is pretty consistent. So one of the things we're exploring is an idea of convention over configuration, which is similar to what we do with Next.js for React. So instead of having to write config, we're exploring this possibility of giving you a cohesive directory structure from which we can intuit what your builders are. So for example, one pattern that the previous talk talked about that I'm a really big fan of is you have public functions, but then you have internal functions that are responding to events. And your internal functions should never really be exposed to the outer world. So there's this categorization that we can make between a worker function, which is one that responds to cron, SQS, events of any kind, and then there's the ones that you want to immediately access through your web browser. And the other interesting thing is there's always going to be stuff that you can serve directly from the edge. And this idea of deploying directly to the CDN comes in very handy here. For example, if a public Lambda responds with cache control, subsequently, the user will get it from the cache at the edge, so you're never going to a specific location. Same with things that are fully static, which you always have. Could be front-end assets, could be assets that are required by the applications once it's running, etc. So that's why we offered this sort of public directory. The problem that we anticipate next is there's not enough configuration. So in the previous talk, you were seeing how there's all these knobs and parameters everywhere. You go to the AWS console and, oh, my buffer size is this and that, and some parts stay in version control and some parts live in the console, and it gets really messy. So, and this is a very important distinction also, that in my definition, I want to categorically divide, which is when you're deploying a lot of functions together as a monolith, either because you're deploying a serverless container or because you're putting all your routes inside one function, you're giving up on a lot of the unique possibilities of serverless. So let's go back to the Express example. What's happening here is I created a process, or even if I put this inside a function, that contains my 2 routes and some static middleware. One issue is from the security model. So now all of a sudden, all my route handlers are getting the environment and secrets all together. So if I have an API key that I need for a specific route handler, like my Stripe API key or whatever, or I need one for SendGrid because I use it from signup, they're going to be all mixed in this surface that is the process. Another one is from a performance standpoint. So some functions require a lot less memory than others. But when you're thinking of a server or a monolithic function, you're assigning the same CPU and memory profile to everything. Routes don't really get their own timeouts, which is really important from a cost management perspective, from a denial of service perspective. When you have a server, you're saying, well, everything can be done for 5 minutes. Everything could take 5 minutes, for example. And compared to the model that I described earlier, like you're basically embedding files inside that function that are not going to be able to be easily optimized from an edge consumption perspective. And what I noticed as well is that when people write servers, they tend to ignore the distinction between doing work at build time versus doing work at runtime. So what we've seen from a lot of our customers is they tend to have heavy middleware that gets in the way and does things that could have been done ahead of time. So solution is we actually need config, but ideally later on. So with sane defaults, we could expose you the ability to decide for the functions that were created as part of your repository, you can assign max memory size or max duration on a per function basis, defaulting to what we consider to be sane defaults. And finally, the next problem that we anticipate, and there's very interesting work that's being done here, is when you write a lot of config, referencing groups of common config becomes very challenging. So this is a typical problem that you find with Kubernetes and gigantic YAML files. So what happens when you become more granular in the configurability of your functions is you have groups of settings that are going to be shared between functions. So even if we do let you set config on a per function basis later on, what happens is that the configuration itself will become very repetitive. So the solution could be potentially code. So if anyone here has seen the Pulumi project, the idea there is, okay, let's use JS as a way of describing our infrastructure, even though I'm doing so statically ahead of time. So the idea here is that we can give you the ability to augment the configuration that we produce from the file system by giving you the ability to set an optional JS file that can extend the configuration of your functions as well. And you would get, as a result, the ability to describe your infrastructure in programmatic terms. And finally, as the Google Cloud Run speaker was saying, there is a need for running all of this in your infrastructure. So even though it's super cool that there's this now global cloud scheduler that relieves all the burden from me, there's still serious challenges with that. One of them that I identify personally is that there's two ways that developers test. One is they run their local development process. And the other one is that you locally want to run the production process. And that's where I think current tooling struggles with. So one of the things we're introducing is the ability for you to reproduce the production workflow. So we have now dev, but separately we have now build, which would allow you to, for example, package your functions. Because at package time, things change as well. So there's this distinction between development with like developer symbols and development with production code. And you could even actually containerize your application if you so desired. Now, I personally wouldn't want to operate a container again, but the ability to package your entire monorepo and run it locally in production mode would technically allow you to containerize it. That's nuts. I don't want to do that. Why would you want to do that? So as I said, first of all, it underlines this idea that there's no lock-in whatsoever, that all the code that you write is very close to the code that your language SDK describes, which I think is really important. There is an advantage that you could have over functions, which is you can technically completely eliminate the matter of code boot times. Because if you can afford it, both from a monitoring perspective and from I run my process all the time, the reality is that you will be able to pre-provision a lot more preloaded code. And like I said, you get to develop in production mode as well, which I think is very important. So if you want to check this out, go to untitled.co/signup and run now init Node.js to get your first Node.js monorepo. Thank you.